Good day, everybody, and once again we are meeting. I know that we have promised to start with our maths lesson, and it's really been a while, but we're off to a good start. And the first thing that I wanted to just start with are number patterns, that is, sequences and series. And this lesson will basically cover the arithmetic sequence. Obviously, we'll build it up and to do some more examples. I hope that you'll enjoy, this series of lessons and the ones that we are still going to be dishing out in the future. What I do ask is that for those of you who are new to the channel, please don't forget to subscribe. We're trying to get to that 50K mark this year and hopefully beyond. Okay, and for those of you who need additional lessons, help with mathematics or physical science, please just make sure to get in touch with us, and our email address is info@mlungisinkosi.co.za. All right, so let's get into the lesson. Okay, so first of all, let's talk about number patterns. What exactly do we mean when we talk about number patterns? Okay. So in a geometric or in an arithmetic sequence, sorry, I'm rushing to geometric. So this is when a pattern increases by a constant number. Okay, so it means that it increments, okay, linearly. We call it a linear pattern. Okay, so it means you are increasing or decreasing by a constant number, by adding or subtracting a constant number. So the general term for an arithmetic sequence is Tn, okay, meaning this is the term. This is going to be A plus n minus 1 multiplied by D. Now, we call this the general term of the sequence, where A, we say that A represents the first term, okay, and we say that D is what we call the common or the constant difference, okay? So this is the common difference, right? I'm going to make an example in just a few so that you know how it works, okay? And obviously N is the, that's the number of the sequence, okay? So it's the nth term of the sequence. So now what I want us to quickly do is just look at how to apply this, right, so that we know how to go about doing questions on the arithmetic sequence. All right, so say we've got a pattern, okay? Our pattern is 5, 9, 13, 17, and 21. All right, so let's start here. Let's identify what is our A, what is our first term. So our first term here is 5, okay? But let's look at what happens in this pattern. To move from the first term to the second term, what happened here? All right, so to move from 5 to 9, we must have added 4. I'm sure you can see that, right? But if you notice again, to get to 13, I must have added another 4. So it seems in this pattern, the constant difference or the common difference is actually 4. So in this case, it means my D value is 4. All right, so now we can actually write the general term of this particular sequence. We can say, well, Tn is equals to A. Remember, our A value is 5, okay, plus, in this case, we know that it's going to be n minus 1, okay, so this is going to be n minus 1 multiplied by D. Please allow me not to go back into, how to derive how we got to this n minus 1 times D. Just at the moment, just appreciate this is how we're going to look at sequences. Of course, the general mathematical rule is that we need to always prove and be able to get to that. Hopefully, in the near future, I'll be able to do that. I won't do that now. Okay, so it means if I want any pattern now, sorry, I actually should have, let me just remove that part. Okay, so I'm just trying to erase there. Okay, so multiplied by d, and we said our d value is 4. Now let's try and simplify that. Okay, so this is going to be 5 plus, when you say 4 times n, this is going to be 4n minus 4. 4 times minus 1, that's going to be minus 4. So if we were to write out this general term of the sequence, it's going to be actually 5 minus 4. This is going to be 1 plus 4n. And you'd see that this is actually even applicable even for the first term. Okay, so now let's have a look at it. Okay, so if we wanted, say, so we've got T1 here, we've got T2 there, we've got T3, T4, and T5. Now let's look at it. How are we going to get to, let's say, T6? In fact, let's prove first that it works for, let's take T3. Does it work for T3? Okay, term 3. Okay, we know that term 3 would be 1 plus, in this case, we're going to say 4 multiplied by, remember what's our n value? Our n value is 3. So we're going to say 4 times 3, that's 12 plus 1, and that gives us 13. And definitely term 3 was 13. Of course, if we wanted to find, and that's where this, deriving of formulae actually comes in quite handy, because you don't want to keep adding and adding and adding and adding. What I want to do is just to plug in a value. Let's say we were looking for T50, okay? So if we're looking for T50, again, we're going to plug in there. So we're going to say 1 plus 4 times 50. And what is 50 times 4? That's going to be 200 plus 1. And so it means that T50 will be 201. Okay, so those are my terms, term 1 to term 2. So it simply means if I were to take the terms, now note, if I ever wanted to work out the common difference, okay, whenever I take the difference between two consecutive terms, let's say T2 minus T1, that should give me the common difference. But similarly, if I say T3 minus T2, that should give me the common difference. So if I go for this one, T2 minus T1, that's 9 minus 5. That should give me 4. But note, even when I take T3, which is 13, minus 9, that also gives me 4. Now, please remember this as a general rule that applies to arithmetic sequences. And you'll see it once we start doing some examples together. You'll see how that applies quite nicely. Okay, so please keep in mind, whenever you've got a common difference, or rather the difference between two consecutive terms will always give us the common difference. All right, so here's what I want us to do. I want us to take a couple of examples. All right, let's take an example together. All right, so we're given there a pattern. So the first term there is 2, and we've got 5, we've got 8 and 11. All right, so first of all, let's determine what type of a sequence is it, okay? So if I note there, to get from 2 to 5, okay, I would have to add 3. But is it the same to get to the third term? So in this case, this would be, of course, I would have to add 3 again. So it means the second term minus the first term, okay, would give me 3. But the third term minus the second term would also give me 3. And so the story goes even for the fourth and third term. So it means that our common difference is 3. So let's say D is equals to T2 minus T1. We haven't started answering the question. We're just determining whether it's an arithmetic sequence. And if it is, then we're going to apply our formula. So we're going to say, so this is T2 minus T1. So that's 5 minus 2, and that gave us 3. And in this case, we also did the same, T3 minus T1. Minus T2, and that also gave us 3. so we can actually determine or we can actually deduce that it is an arithmetic sequence. Obviously would have done the same with T3 minus T2 and T4 minus T3 as well, also gave us 3. So it means, therefore, this must be an arithmetic sequence. And we know once it's an arithmetic sequence, we know that our formula Tn is equals to A plus n minus 1 times D is applicable. So we said our A value in this case, so we know our A value is 2, and we've determined our D value is equal to 3. So let's try and get that general formula for this guy, okay, and simplify it. So we know that our A value, we said it's 2, plus our n minus 1, this is multiplied by 3. So this is going to be 2 plus, once again, we're going to multiply into the bracket, 3 times n, this is going to be 3n minus 3. And so as a result, we've got two common factors there, 2 and minus 3. That should give us minus 1. Okay, and please remember, whenever we are adding or subtracting, we've got two numbers here. The one has got a positive and the one has a negative. So we know that we are adding. In this particular case, we take the sign of the bigger number. So in this case, we ended up with a negative, and the numbers themselves will subtract each other. So this will be minus 3 plus 2. That will give us minus 1 plus 3n. Okay, so this, we've got Tn over there. Okay, so this is the general term. Now let's answer the question. They say determine the 18th term. Okay, so the first question said determine the 18th term of this sequence. So let's do that. So it means we're looking for T18. We already have the general formula. So this is going to be minus 1 plus 3 into our n value. They said the 18th term. So in this case, we're going to say multiplied by 18. And in this case, quickly 3 multiplied by 18, that will give us 54, and we subtract 1 from that, and in this case we end up with 53. So it means that the 18th term is 53. Okay, right. Now they say which term is equal to 242. So we've answered the first question here. So we want to know which term is actually equal to 242. So we know that Tn, again, this is our general formula, we derived it there, is equals to minus 1 plus 3n. Okay, so we want to know in this case which term would give us 242. So remember, Tn in this case, the term would actually give us that number 242. Okay, so now we can just simply solve for x and say, well, look, we've got an equation here. It's a linear equation. So what that tells us is that we can now use our linear equations. Okay, so minus 1 plus 3n. So let's just try and get this guy to the other side. So this is minus 1 plus 3n is equal to 242. I'm just trying to write it more neatly so that you can see it. So now I'm going to take the minus 1 to the other side. Of course, it changes sign when it goes to the other side. So we are going to have 3n left only on the left-hand side. And then the minus 1 becomes a plus 1. And so we've got 243. And we can divide both sides by 3 now. Okay, so let's say 243. Divide that by 3. And that gives me 81. So it means that 242 is the 81st term. Okay, so that is n is 81. All right, so I hope that is helpful. I hope that makes sense. All right, so let's look at example number 2. All right, so they give us a sequence there. They say the following sequence is an arithmetic sequence. So by virtue of them having told us that, it means that we can apply, what we know about the arithmetic sequence. So we've got, they've given us the first three terms there, which is 2x minus 4. 5x is the second term, and the third one is 7x minus 4. They say determine the value of x. Now, first of all, let's do this. So what do we know about an arithmetic sequence? We do know that the common difference, okay, it means that the difference between the two consecutive terms is actually the common difference. So let's find out what that common difference is. So let's take term 2 minus term 1, okay? So in this case, what do we have? We've got 5x minus, okay, I'm going to put it in brackets, 2x minus 4, because remember, we're subtracting the whole thing, right? So let's try and simplify that. So that's going to be 5x minus 2x, right? Negative times a positive there. That would give us a negative, but now note, a negative times a negative would give us a positive, okay? So remember, negative times a positive gives us a negative, so that we got the minus 2x there. And then a negative times a negative gives us a positive, so that will be a plus 4 over there. Please don't forget those, those little gymnastics there, because they do make quite a bit of a difference, okay? So 5x minus 2x, that will give me 3x. And plus 4. Okay, so we only had two common terms there. Okay, so that's 5x minus 2x, that gave me 3x. Right, so this is the expression for my common difference, isn't it? Okay, however, in this case, we want to solve for that x term. So again, remember that the common difference can also be expressed by T3 minus T2. Okay, so let's take the second term minus the third term minus the second term, okay, the difference between the two. So we've got 7x minus 4, which is also equal to, not equal to, rather, we're subtracting there, minus 5x, which is our second term. Right, now let's try and simplify that quickly. So we've got 7x minus 5x. Those are the two terms that are common. So we're going to say this is 2x minus 4. And as a result, that is our common difference. Now, of course, we've got these two expressions, but what do we know? We know that this expression here, let's call it equation 1. And this expression here, let's call it equation 2. These are exactly, they represent the same thing. So what can we say? It means that equation 1 is actually equal to equation 2, right? So we're going to say, well, it means that 3x plus 4 must therefore be equal to 2x minus 4. So let's try and solve that quickly so that we get the value of x. So if we take the common terms, I'm going to take the 2x, I'm going to bring it over to the other side. It's positive on the right hand side, so when it goes to the other side, it becomes negative. Of course, you should have learned this by now, okay, but nonetheless, so we're going to say x. Now I'm going to take the 4 to the other side. We're trying to solve here for x, so taking the 4 to the other side, it becomes negative, so x would be minus 8. So I'll have minus 4, minus 4. Remember, when it jumps to the other side, it becomes negative, so I've got minus 4 and minus 4, and therefore that gives me minus 8 and negative 8, right? All right, so in this case, we've solved the first thing. We know now that the value of x is negative 8. Right, now quickly what we want to do, they say determine the first three terms of the sequence. Okay, that's the second thing that they had asked us to do. So very simple here. What we're going to do is just substitute for x in the respective expressions that they have for each term, right? So we're going to say, all right, substitute for x there in the first expression. Okay, so in the first expression, remember we had 2x minus 4, so we're going to substitute for x in the expressions. Okay, I just want you to know what I'm doing. Okay, so in this case I've got 2x, was it minus 4 or yeah, 2x minus 4, so that's 2 times, in fact maybe I should have 2 times minus 8 plus minus 4. Okay, so that should be minus 4. Okay, so that's the first one. In the second one I had 5. Continuing right along, so we've got in the second one we had 5x, so that's 5 times minus 8. And in the third one, let's just quickly check. In the third one we've got 7x minus 4, so that's 7 times minus 8 minus 4. Okay, right, now let's check our first 3 sequences, and we should have actually made it quite clear there. We are answering 2.2. okay, and now let's try and get that quickly. So that's minus 16 minus 4. I've got minus 20 for the first one. In the second one I've got 5 times negative 8. Okay, and I've got minus 40. And in the third one I've got 7 times negative 8 and minus 4, so that's going to be minus 56 minus 4, and that would simply give me minus 60. Okay, and so that's my sequence. But now what I want to do is see, is this really an arithmetic sequence? Okay, so if I took the difference between the first and the second term, all right, so we want to know what's the real value for d. Okay, so if I took the difference between the two, minus 40 minus 20, and please remember, so d is t2 minus t1, that would be minus 40 minus a negative 20. Okay, please don't forget that. So what's happened here? So I would have, now note, minus 40, negative times a negative would be a positive, so I end up with minus 40 plus 20, and this would be minus 20. So it means that I've added by a negative 20 to get to the next term. Okay, let's see if that is the case. If I take, again, t3 minus t2, so this would be minus 60 minus a negative 40. Okay, and you'll see that you get exactly the same thing, which is minus 20. So yes, we do have a common difference. And of course, you can work out, if you want to, the general formula. So it means that we've got the first 3 terms. There they are there. Okay, now we know what's the first term. It's minus 20, negative 20, and we know what is the common difference. All right, so I want to leave it here, and in the next lesson, what I want to tackle is to look at the sum of the arithmetic sequence, and we are definitely going to be building this up. And please don't forget to subscribe to our channel, and we'll be dishing out even more content when it comes to mathematics. I'll try to expedite that so that we can be able to cover the syllabus. Of course, I want you to get those distinctions ultimately. All right, and from me for now, I'll see you guys next time. Sharp, sharp.